Hello ELM 258 students. Welcome back to another Automation Studio tutorial. In this one I'm going to demonstrate Virtual Lab 4. What we're going to do in Virtual Lab 4 is take the electropneumatic circuit from Virtual Lab 3, and in the electrical part we're going to replace the hardwired circuit with a PLC and have a ladder logic program, perform the function. You're going to create three different ladder logic programs, or three different circuits that are going to perform the same functions as in Virtual Labs 2 and 3, but in this case, as I mentioned, we're going to have the programmed component of it. So you should have Virtual Lab 3 done before you start this lab. I have Virtual Lab 3 open, and first thing I'm going to do is save it under a new name. So go to Save Project As, and we're going to be creating three programs in Virtual Lab 4. So I'm going to call this Virtual Lab 4. I'll call it PLC 1. Save that. And then I'm going to delete everything that's not part of the first circuit. We're just going to use the cylinder A and the valve A and some of these components. So I'm just going to get rid of the one that we labeled C and the one that we labeled B. Okay, on this one, I'm just going to delete, I'm going to reuse some of the components here. So I'm just going to delete the connections, and I'll put the push buttons and the solenoids just off to the side a little bit. Put the solenoids down here and put the push buttons up here. I'll get rid of this line. And we'll also be using the 24 volt and 0 volt. Okay, so the PLC, I should move this over a little bit. All right, I'm just going to close up the menu. The PLC is going to be found in electrical control. Now, we've been staying with the IEC standard, so we're going to stay with that. If you expand that, down at the bottom is PLC cards. And what this has is an input card and an output card. So we're going to put the input card here. And looks like I'm going to need a little more room. So I'm going to move these down. And the output card here. This is also very similar to the way the HAS 200 is drawn, with the inputs kind of coming in vertically. So to wire these up, for the input side, the common is connected to ground, to 0 volts. And the switches are sourcing switches. The inputs are syncing. So the other side of each switch is connected to 24 volts. Now I want to get these components lined up close together with the inputs. So what you can do is, if you right click the label here, extend, go to transformation, you can rotate it so it points up, and then you can just tuck it right in here. Same thing with this. All right, and then I can just put it right next to the other one so it lines up with the input. And then we're going to connect 24 volts to one side of each of these switches, and then the other side goes into the input. So that's an active high input. When you press the button, it's going to apply 24 volts to the PLC input. Okay, on the output side, we're going to have these are the two solenoids, and so one of them is going to connect to out 0, and the other is going to connect to out 1. I think what I'll do is I'll take the labels and maybe I'll stick them right on top of the component so it's easy to see which one is which. And now I can bring it in a little closer. Okay, so the one side of the solenoid is connected to 0 volts. Now we need a common connection, so we're going to use the 24 volt as the common. So remember, with a PLC, whatever voltage you tie to common gets switched internally to the output. If you don't put a voltage there, then there's nothing that will go to the output. Oops, now I'm going to connect this one. Okay. So now the connection between the extend and retract buttons and the two solenoids is going to be performed in software with the PLC. So now we need to put a ladder diagram in. Before I do that, I'm just going to move this in a little closer so we'll be able to see everything working. In fact, I'm going to move just a little out and do a zoom view, zoom window. That'll show us just what we need. Okay, so to get the ladder diagram in here, what I'm going to do is go to the home menu, and under the document section I click on ladder diagram, and I've got a few choices here. We're going to stay with the Allen Bradley 500. I know the HAS 200 is the 5000, and we might work with that in another tutorial, but I'm going to start with the Allen Bradley 500 because it's a little more basic. Click OK, and it creates a separate window. So I want to see both windows at the same time. So up here in the upper right, there's a little that can make the windows kind of not minimized, but they're kind of floating windows, and I can put them wherever I want. So just going to arrange them here so they're right next to each other. Maybe I'll make this a little narrower so I can see the whole diagram. Okay, now I have to configure the PLC. So just like if you were starting a PLC program, you would have to create addresses for the different inputs. And so that's what we're going to do. We're going to go to the ladder menu up here. You might have to you have to click the window that says ladder first, and then the ladder window will appear. The ladder menu will appear. And the first thing I'm going to do is this PLC configurator. So this is where I'm going to make the connection between the electrical diagram over here and the ladder diagram over here. Whatever inputs and outputs I'm using, I need to add them here. So there's a little icon that says add input output. If you click on that, what you'll see is a list that comes up, and on that list is the names of the different inputs and outputs. So we're going to start with in 0. All you have to do is just double click it and it appears up in the list. And I guess while we're here, we might as well double click in 1 as well. All right, we'll come back to that. So we have to give it an address, a PLC address. So the syntax in Automation Studio is I for input, which is typical, then a colon. Now it's 0.0, so that's slot 0, sub-element 0. I know in a lot of addressing the sub-element is not used, and you have a more simplified address, which would be like I:0/0 1 or whatever the bit number is. So in0 has the address I colon 0.0/0. And we're going to give it an alias, which is basically the name of the input. So we've got the extend button connected. So we're going to put that in here. So that's when we do the ladder diagram, it will come up with the address, but also the label that we can create so we understand what its function is. And then in1 is just I colon 0.0/1, and that's the retract button input. Okay, and now we have to add the two outputs. So we go back here to add input output, and out 0 and out 1 should be down here on the list. There we are. Double click out 0, double click out 1. Okay, now this is going to be an output address, and this is going to be O colon 0.0/0, O colon 0.0/1. And the alias is on that. So I discovered this by trial and error, but I want the alias to be the same as the name or similar to the name. So, but if I type A plus, you see how it has a red outline around the box, and I'm getting the message that the alias is invalid. So I can't use plus sign. I can only use like alphanumeric. It says alphanumeric and underline characters, and it can't begin with a number. So what I'm going to do, instead of a plus sign, I'm going to spell out PLUS, A plus. And the next one is going to be A minus, spell it out. Okay, now that I have the outputs and inputs addressed and labeled, I'm going to close that up. And up here under, let's see, actually on the menu, ladder for Allen Bradley PLC, if I just click that, actually here it is, ladder for Allen Bradley 500 PLC. It brings up the most of the common components. Now there's some, if you drill down later on, we're going to be using some other things like timers in another lab, but for now we just need the basics. So we've got this thing called the power rail, which is the basic rung structure, and I'm just going to do a view zoom window so I'm only seeing what I need to see, and it's bigger. Okay, so this is going to be a pretty simple program. The extend button is going to actuate the extend solenoid A plus, and the retract is going to actuate the A minus. So we need an input, and as soon as I place the input, it's asking for me to label it. So if I scroll down below here, all the labels that I created are down here. So this is the first input. It's going to be the extend. Double click it, and that's it. It's addressed. And then the output over here, same thing. Just scroll down the list, and that's going to be the A plus. And I'm just going to connect that rung. Okay, and then we need another rung. It's going to look very similar. This is the retract button, so double click retract, and here this is the A minus output, which performs the retract. And I'm going to close, connect those up. Oops, I didn't put it where it needs to be. Move that up, okay. Okay, that's it. That's the basic PLC program. That's the PLC wiring, and here's the pneumatic. So I'm going to just hit simulation. And so when I hit the extend button, it extends. So I hit the retract button, it retracts. So in this case, we've got 3 levels of function that are happening. There's the actual physical electrical connection when I press the button, which lights up the input. And you see that when I press that button, you look in the program, the extend button highlights, and the program makes the A plus output go true based on this rung. As soon as that goes true, the output A plus goes true. And then that's what actually makes the valve, the A plus, electrically actuate and move the valve over and cause it to extend. And then the retract button, the electrical signal goes into in1. The software inside the PLC runs the ladder logic diagram, which retract makes A minus go true. You see the A minus output is green here as long as I hold the button down, and that's what causes it to retract. So now that we know everything is working, make sure you save it. And we're going to create 2 more circuits that are similar, that have variations. We don't want to have to start from scratch. So what you should do is save as, project save as, and I'm going to call this Virtual Lab 04 PLC 2.